Participants were shown the focus trajectories in blue, then the transition was played. They had to answer the question, does the stationary trajectory go under the trajectory that changes altitude? In the second experiment, participants had to identify the letter being displayed in the rotating cube. Different density levels and axes of rotation were tested. This display shows one day of aircraft traffic in France. This is zoomed in on Paris airports. When switching to the vertical view of this data, we can't see the aircraft traffic landing in Paris. The focus trajectories disappear. In order to track the focus trajectories, the user brushes them. Here the user is brushing the aircraft landing in Paris in the top view. Using the mouse wheel, the user selects the depth of the rotation by highlighting the focus trajectories in red. Then the user switches to the vertical view and the focus trajectories do not disappear. The user is able to see the aircraft landing in Paris. During the transition from the top to the vertical view, users can perceive particular structural elements such as an unusual trajectory. The global transition hinders their perception in a dense view. The user places a sizable lens where the particular trajectory has been seen. Then the user can control the transition within the lens and sees that this particular trajectory is a figure 8. The full animation is played within the lens. This is the top view of aircraft landing and taking off at Paris-Orly Airport. The user wants to verify if landing aircraft pass over aircraft taking off. The user brushes the intersection of the trajectories. Using mouse drag, the user controls the stage transition. During the transition, the user validates that landing aircraft do indeed pass over aircraft taking off. This scatter plot visualization shows aircraft speeds. The x component of the speed is mapped to the x-axis of the view. The y component is mapped to the y-axis. The outer disk we can see corresponds to high-speed aircraft. The inner disk corresponds to low-speed aircraft. In order to analyze these aircraft speeds, the user brushes a cluster of aircraft with a slow speed in the inner disk. This cluster corresponds to landing aircraft. Now the user wants to visualize the speed distribution by altitude. This is done by mapping the altitude on the y-axis. The user selects the depth of the rotation by highlighting the selected graphical marks and zooms in. Then a staged transition can be performed using the mouse drag. Firstly, the view is rotated to the right and the transition showing aircraft speeds on the x-axis and the aircraft altitudes on the y-axis is played. As a result of this transition, the user is able to perceive the structure of this cluster. This cluster shows the different speeds of landing aircraft. The green area shows aircraft above the 160 flight level, where air traffic controllers control the aircraft speed. The red area shows aircraft that have been given clearance to land and are no longer constrained by the speeds determined by the air traffic controllers. Therefore, the green area has a more limited speed range and the red area shows a larger range of speeds.